Welcome to the deep dive. Today we're tackling a really persistent challenge in software, the crash. That moment everything just stops.
Right. And we're not just talking about the frustration, are we? We're looking at a new way to figure out why it happened using AI.
Exactly. For years, when an application just goes kaput, figuring out the reason felt like trying to read ancient hieroglyphics.
Yeah, lots of obscure commands, squinting at hexadecimal numbers, and frankly, a fair bit of guesswork sometimes.
Well, there's this potentially game-changing tool from software engineer Sven Sharmenka. He goes by Svencha online.
Ah, yes, mcp-windbg.
That's the one. And he's made it open source. It's right there on GitHub for anyone to check out.
Which is great.
So if you've ever been completely lost trying to analyze a crash dump file, this could be, well, huge.
It's like Sven's analogy, moving from stone spears for hunting bugs.
To the guided missile. I like that. So our mission today is to really unpack this.
Yeah.
How does this AI tool actually work? What can it really do? And what does it mean for, well, anyone who deals with software glitches?
Okay, so maybe let's start with the before picture. To really get why this is different, we need to paint a picture of how crash analysis usually works, even now in 2025.
Right, the traditional way.
Yeah. Picture a developer, maybe support staff, staring at a black command prompt window. They're typing these, well, pretty arcane commands, things like .analyze-v or .ecxr.
Things you probably have to look up half the time unless you live in that world.
Absolutely. And you're wading through lines and lines of hexadecimal addresses, trying to make sense of stack traces, which are basically the footprints the program left before it tripped.
It feels quite disconnected from the, high-level code most developers are actually writing day to day.
It really does. Almost jarring, like you said. We've got AI helping us write code, suggesting completions, finding patterns.
But then a crash happens and bam, you're back to what feels like 1990s command line tooling.
Exactly. It does make you wonder, like Svencha did, why debugging sometimes feels like it's stuck in the past.
So that disconnect, that was the spark.
Pretty much. Svencha called it a lightning bolt moment. He thought, hang on, if AI is getting so good at understanding code,
And even suggesting fixes.
then why can't we apply that same intelligence to the puzzle of figuring out why the code crashed?
Makes sense.
What if you could just ask, in plain English, hey, why did this app crash right here, and actually get a useful answer?
And that's the core idea behind mcp-windbg. Now, it's key to understand this isn't some magic AI that just knows.
No, not at all. It's more like a translator or an intermediary.
Yeah, bridge. It connects large language models. The demos show GitHub Copilot quite a bit.
Right, Copilot.
It connects them to WinDBG. That's Microsoft's main debugger for Windows. Powerful, but let's be honest, pretty intimidating for many.
It definitely has a steep learning curve. So the how is important here. How does this bridge work?
It uses something called the Model Context Protocol, MCP.
Okay, MCP, what's that?
Think of it as a standard language, a set of rules that lets different AI models talk to and even control other software tools like WinDBG.
Ah, so it's like a universal remote for AI to use tools.
Kind of, yeah. It makes sure the AI's requests to WinDBG are understood, and the answers from WinDBG make sense to the AI. It standardizes that communication.
Okay, I see. So mcp-windb implements this MCP?
Exactly. It acts as an MCP server specifically for WinDBG, or technically for its command line version, CDB.
CDB, the console debugger.
Right. And using CDB was a smart move, Sven points out, because it just works with text input and text output. Much easier to hook into programmatically than a complex graphical tool.
Simpler integration. Got it. So instead of me typing .analyzed-mdvsh,
That AI, like Copilot, sends that command through the MCP server to CDB. CDB runs it, sends the text output back.
and the AI interprets that text dump and explains it in hopefully clearer terms.
That's the idea. It automates that whole tedious cycle. Type command, read output, try to understand, type next command.
Okay, that starts to sound genuinely useful. The demos must show this in action.
They really do. In one video, Svencha installs mcp-windbg, runs an app he knows will crash, and then just asks Copilot in natural language, something like, analyze this crash dump and tell me what went wrong in the code.
And what happens?
Well, the AI comes back pretty quickly. It identifies the crash type, explains why it happened, like this variable was null right here when it shouldn't have been.
Wow.
And it even suggests a code fix, all from that natural language prompt.
That's quite a leap from staring at hex codes and memory addresses.
Isn't it? And another demo shows it tackling multiple crash dumps at once.
Oh, interesting. Like if you have a bunch from different users.
Exactly. The tool quickly scans them, gives the initial analysis for each, points out maybe common themes or unique problems.
The speed must be a huge factor there, getting that first pass analysis done fast.
Definitely. Sven even mentioned seeing the AI use WinDBG commands he hadn't personally used much, despite his experience. The AI is leveraging its vast training data on debugging.
Okay, so let's break down the benefits. The most obvious one seems to be this natural language interaction.
Right. Asking, why did I get an access violation at this address?
Yeah.
Instead of needing the specific WinDBG syntax.
And that leads to more contextual debugging, presumably.
Yeah, imagine asking for the call stack for the thread that crashed.
The sequence of function calls.
And then asking the AI, okay, what do these functions actually do? It can explain their likely roles based on the symbols, the names, and the code.
That's a huge help for just understanding the flow. What about finding the root cause?
That's the goal. You could encounter, say, a null pointer dereference, a super common crash type,
Yep.
and ask the AI, why did this pointer become null? And maybe get pointed toward the specific lines of code to investigate.
Okay, the potential for saving time here seems enormous.
Absolutely. Think about software engineers, support teams trying to reproduce customer issues, QA folks tracking down bugs.
It could automate a big chunk of that initial, often frustrating analysis work. Hours down to minutes, potentially.
Potentially for that first assessment, yeah. It could really boost productivity.
And maybe lower the barrier to entry a bit. Like, you might not need to be a WinDBG guru to get a basic idea of what's going on.
That's another interesting aspect, democratization. Maybe someone less experienced could get a handle on a crash without needing years of deep diving into debugger commands.
It's leveraging what AI is good at, right? Parsing complex text, assembly code, checking memory values, following data structures, things that are tedious for humans.
Exactly. But we need to pump the brakes slightly. This isn't magic.
Right. Important caveats.
Sven himself is clear on this. AI models don't think like humans. They find patterns.
So treat the answers with skepticism.
Healthy skepticism, definitely. Don't just blindly trust what the AI says. It's a tool, an assistant, not an oracle.
And it doesn't replace fundamental debugging skills. You still need to understand the basics to use it well and judge its output.
Absolutely. As Zen describes it, mcp-windbg is essentially a simple Python wrapper around CDB. It relies on the LLM already having been trained on WinDBG commands and debugging concepts. The real power is still WinDBG and the AI's training data.
It's a clever interface to that power.
Precisely. Now, for anyone listening who's technically savvy and wants to try this,
What's involved?
well, the basics are you need the Windows SDK installed, specifically the debugging tools for Windows part.
Okay, that gives you WinDBG and CDB.
Then you clone the mcp-windbg project from GitHub, set up Python, install requirements.
Standard open source setup.
Pretty much. And then configure your editor, like VS Code, using a little file called mcp.json so it knows how to talk to the mcp-windbg server you'll run.
The details are presumably on the GitHub page.
Oh yeah, Sven's laid it out there.
Okay. So wrapping this up, what we're really seeing is AI being applied to make a historically complex, time-consuming part of software development much, much simpler.
Yeah, moving away from pure manual command line work towards something more conversational, AI-assisted.
It feels like a significant shift.
It really does. From those often cryptic commands to asking questions. It really makes you wonder, doesn't it?
About what else could change.
Yeah. What other parts of software development, or even just tasks in any field, are still stuck using those stone spear methods? Where else could an AI assistant, a guided missile, make a huge difference?
What a good question. Makes you think about your own workflows.
Exactly. Even if you're not a software developer wrestling with crash dumps, think about it.
Yeah.
What tedious process, your daily routine, feels ripe for an AI upgrade? What could an AI assistant potentially tackle for you down the line?